PowerPoint. There it is. Play from start. Can you see the PowerPoint? And can you see me getting my coffee? Oh, I'm tired. So, now it's recording. There's the heart. There's the heart. Looks like a transverse cut. So, there you go. We're probably looking down into the heart. So we call this thing that the heart's sitting in. It's probably on another slide. It's not on this slide, but it's oh, right here. Look at the bottom here. It's called mediastinum. Oh, and it's here too. Mediastinum. That's just a cavity that the heart sits in. So in one of the videos, I was explaining that we're really talking about an exchange between the air outside and all of our tissues. We want to get the oxygen from the air into our bodies, and we want to get it to all the tissues or cells, right? Your book might say tissues. We're really talking about cells. We want to get the oxygen to our cells. Then we want to get the carbon dioxide, which is a waste product, out of our cells and back out into the air. So that's really what's going on, right? This air from the air going in, grabbing the carbon dioxide and taking it back out. The heart is the pump that's making this happen. The heart is, so when air comes into our lungs, the heart takes that blood and sends that blood to all of our cells. And even if you go the other way, from like the cells, like when the cells got all this carbon dioxide, the heart's going to take all that blood with that carbon dioxide in it and deliver that blood to the lungs so that we can breathe it out. So we've actually got two types of blood. I'm not actually getting to anything here. I'll just leave it here. I'll leave it here. So we've actually got two types of blood in our bodies. I always call it oxygenated blood and deoxygenated blood. You know, the other terms, I think your book calls it oxygen rich and oxygen poor blood, which is a better way to put it. Because how do I get back? It's a better way to put it because even the even the blood in your veins that's deoxygenated, it still has oxygen in it, just not as much, right? So if you even take in my arm, right, I've got two different types of blood vessels in here, right? I've got arteries, and you can kind of, no, you can't. I've got arteries that are deep down, and I've got veins that you can see, right? So the veins are going this way, and the arteries are going that way, at least in my arm. So the arteries, which are deeper down, are carrying oxygenated blood. That's blood getting pumped out from my heart, coming around my shoulder, down my arm, and it's feeding my arm and hand with oxygen. And now, once my hand gets oxygen, now there's like a waste product, right? Carbon dioxide. So that's all going to go into the veins, which you can kind of see on me. Maybe you can't see it. I don't know why I keep, but it's coming down the veins. It's going to go around my shoulder and back into the heart. So the heart's always getting this blood. Your blood never goes straight from my hand to my lungs and then out. The heart's always in the middle. The heart's the middleman. The heart's like, okay, hand, give me the deoxygenated blood. I'll give it to the lungs so that you can breathe it out. And then when I breathe in new oxygen, the heart's like, yeah, give that back to me. I'm going to ship that out to the whole body. So you've got like the lungs, you've got all your cells, you've got the heart in the middle. It's like mediating between both sides. So You've got two different types of blood in your body: oxygenated, deoxygenated blood. And they use different vessels to go in. So here's a look at the heart. Well, that's the back. Here's the front side of the heart. All right, so here's the heart, the actual heart. Okay, so there's the actual heart. You really can't tell a whole lot of stuff until you start cutting away at it. But notice how I'm looking at the back side of the heart now. Notice how this side's in blue and this side's in red, right? And I'll show you another one. This side's in red. This side, it's kind of hard to see. But it's like blue. Like these vessels here are red and it's kind of on this side. And these vessels are blue and it's kind of on this side. So the heart carries different types of blood. The left side of the heart only deals with oxygenated blood. So I could draw a line right down the middle here and split this heart in half as far as like what blood they carry. This side, which is the right side, remember the heart's facing you. It's an anatomical position. So you treat the heart like as if I'm facing you, right? So this is my left side. This is the left side and this is the right side, right? So this heart's facing you. So this is the left side. This is the right side. The left side's only going to deal with oxygenated blood or oxygen-rich blood. The right side of the heart is only going to deal with oxygen-poor blood, aka deoxygenated blood. So far so good. The heart's a pump. One side is for oxygenated, one side's for deoxygenated.
You're talking about like the heart right side or like our right side?
I'm talking about the heart right side. Pretend that this heart belongs to somebody that's standing and facing you.
Okay.
Someone took a machete and just sliced right through from the side of them and just sliced through them.
Left is oxygenated, right is arterial.
Right is deoxygenated.
Yes.
So there's a left side, there's a right side. Now there's a top and a bottom, I guess we could say. There's parts of the heart that their job is just to receive blood, and then there's parts of the heart that is just to ship blood out. So there's like, I always think of it as a receiving department and a shipping department. The receiving department are the atria. So here's the atrium. Both of these, like this one here, that's the left atrium. This is the right atrium. They receive blood, that's it. Blood drops into these two chambers. What type of blood? Well, we already know. So what type of blood is this that's going into the right atrium? It's on the right side.
Poor blood.
Yeah, it's oxygen poor blood, deoxygenated blood. And then on the left side, this is oxygenated. So I'm going to ask you a question, like where the blood's coming from. Like over here on this left side, where's this blood coming from? You have two choices. It could be coming from the lungs, or it could be coming from all your cells in your body. So we're on the left side here. Where did it come from?
The lungs.
Yes. It came from the lungs because that stuff's oxygenated. The lungs got oxygen and it came from there. It wouldn't come from like all your cells in your body. That stuff's all used up oxygen, it's all carbon dioxide. So we're not going to send that into this side of the heart. The stuff that came from all your cells with all the, oxygen poor blood, we're going to send it over to this side of the heart. So whatever this is and whatever this is, they're dumping into here. That's deoxygenated. This is coming from all your veins. All right, see, this is called like superior vena cava. That's like my neck. The veins in my neck, they're coming down and they're dropping into the heart. Or this vein in this arm, right? It's coming around the shoulder, right? So it's coming around the shoulder and then they're not really showing you, but it's going to come around my shoulder and it's going to drop into here. And then it's going to go into this side of the heart. So all that stuff in my veins doesn't have oxygen in it. So it's coming around here. It's dropping into my vena cava. It's going to drop into the heart. There's very low amount of oxygen. So my heart needs to send this blood out somewhere in your body that you can get oxygen from. So what we're going to do is we're going to pass this blood off to the shipping department, which is the ventricle. See, here's one ventricle here. Here's another ventricle here. So the receiving departments, the atria, they get the blood. Then they turn around and give it to, they like walk it through the door into the back of the warehouse and give it to the shipping department. So here's the ventricle. Hey, shipping department, I've got blood with like no oxygen. Go send this out to the lungs. Go send it over to the lungs. They've got to stick some oxygen in it. Man, I was so aggressive with my coffee drinking. Thank God I got that little thing over my camera. Now I'm going to watch the recording though. I'm going to like stop it right where my face realize that it's a cough and I can't do anything about it. Or I could just edit it out, which I'm not. It takes too long. So here comes some blood, deoxygenated. It's coming into the right atrium. The right atrium is going to get it, and it's going to send it to the right ventricle, shipping department. Now, the right ventricle's got to send this stuff out to the lungs to get it oxygenated, and then we'll get it back. So send it out to the lungs. The lungs are going to put the oxygen in that blood, and then the heart's going to take that blood back. And so you can see, if you follow like my arrow, you can see how this is going to happen. Here's the deoxygenated blood. We're going to exit the door of the warehouse, get onto the truck, drive over this way. We're going to the lungs. Look, even if you see the names on these things, we're going to the lungs. Here's the lungs right next door. Get some oxygen. It's got oxygen now. So now it was changed from deoxygenated blood to oxygenated. That happens over in the lungs. So now it's oxygenated. Turn around, come back. Get on another truck. Into the receiving department of the other side of the building. Because this is now, now we're on the left side. So it exited from the right side. It's returning to the left side because it exited as deoxygenated blood and it went to the lungs. Now it's returning as oxygenated blood. So then in that case, we send it to the right side. So now the thing is, we have oxygenated blood. What are we going to do with it? Well, we got to ship that stuff out. You've got cells waiting on it, right? So go walk through the door, give it to the shipping department. Hey, shipping department, go send this shit out to all the cells. And they're going to pump it out, exit the building. Here's like a little door. Exit the building, get on the truck. Bam, this from here, it's going to go to everywhere in the body. Like these are going up the neck and around the arms. This thing's dropping behind the heart. It's like here. You see, like it continues down. And from here, that's going to go to, you know, your stomach, your intestines, legs. That's all oxygenated blood. We're sending all of that to our cells. And of course, we're going to hand that to the cells. And then the cells are going to be like, well, hold on, I got something for you. And it's going to give you all its garbage that it had. And then now the blood's a different type of blood. Think about it this way. Like, what if you had like Amazon drivers, like delivering whole food stuff, right? And you get to the house and you drop off all the food. And then they're like, well, hold on a minute. Let me give you all the shit that we've been storing for the last few days. And they just give you a bunch of garbage, food scraps and stuff like that. So now you were a food delivery car, and you put all this stuff in there. Now you're like a garbage truck. So what do you got to do? You got to go like get all that stuff out of your car. So they're headed back to the heart again. Come back to the heart. Go to the receiving area. The atria. The atria is going to handle that off to the ventricles. And it's just going to keep going like that. The ventricles are going to ship that blood out to the lungs. And it comes back in through the lungs. Do you want me to try to write it in a different way?
I'm just looking at it like a big packaging company.
I don't know why I think of it that way. I'm going to write it up on the board. Let's look at the heart a different way. Let's just make it more like a company. There's the business. I can even make that bigger. It's like a big building. That's our heart, right? But it's actually a building with there are two different businesses in that building, right? So they've got like a receptionist here when you walk in, one here. These are two different businesses, but the same building. What's their jobs? Well, let's label right and left first. I'm going reverse here, right? Because it's reverse because it's facing you. It's my right and my left. That's how they show up in books. So we got a right and a left side. It's like a duplex. Right, so you've got receiving department. You've got a receiving department on both sides. And you've got a shipping department on both sides. They both receive and ship different products. The right and the left deal with different products. They don't mix. They don't share a lunchroom. They don't talk with each other. They're different businesses, just the same building. Because this side only deals with oxygenated blood. Oxygen-rich blood. This side only deals with deoxygenated. Or you could say oxygen-poor blood. Right? So they don't They deal with different products. Whatever comes in this side is going to leave through that side. If you come into the right, you're going to leave through the right. So let's put where this stuff's coming from. This blood that's going to come in here is deoxygenated. So I know where this comes from. It didn't come from the lungs. If it came from the lungs, it would be oxygenated. This came from all your tissues or your cells. This was in my foot. This was in my brain. This was all blood that my body used. This was in my hands. I've used it. It's used blood. We used all the oxygen out of it. So we're going to send it back to the heart so that the heart can go get us some more good blood. And so that's what happens. The right atrium is going to hand it to the shipping department. All right, so you're working in the receiving department. You take all that blood that is like no oxygen in it. You walk through the door and you're like, "Hey, shipping dudes, send this shit out because it's like not any good. Go send it out and make it good again." And so they're going to grab it and they're sending it out. And they're going to send it out. They're going to send it out to the lungs because that's where you get oxygen, right? From your lungs. They're going to send it out to the lungs. So it comes from all your cells. It's going like through all your veins and coming up around here, going to my heart. My heart gets it, and it's got to send it to my lungs right next door to get oxygenated. So this blood is now going, this blood that used to be in your arms and feet and brain, it's now headed to your lungs to get oxygen. Now it's coming back from the lungs. And look what I did. I changed colors because I like to keep things fire. That's how I... Oh, we got somebody coming in. Lit, is that a better word? Because I keep things lit? Whatever. All right. Coming from the lungs, it's a different blood. This blood that left was deoxygenated. Now it's coming back. It's oxygenated. Because the lungs got that deoxygenated blood and they oxygenated it. They stuck more oxygen in it. And they're like, okay, let's send it right back to the heart. So there it is. Now it's on the left side. Left atrium. Left atrium is going to turn around and give it to the ventricle. Hey, ventricle, I've got oxygenated blood. Go send this out to all those cells. Send it out everywhere to tissues or cells. Cells are tissues. Send it out. Then it goes out to all of my tissues. I'm going to use up all the oxygen. I'm going to give the blood back carbon dioxide. And then that blood's going to end up coming back to this side. Same thing. Go to the lungs, get oxygenated. Go out to all your cells, get deoxygenated. Come back to the right side. Go out to the lungs to get oxygenated. Come back from the lungs. Send that out to the cells. They're going to be deoxygenated. Come back to this side. So it's just going like this. It's coming out that way, then it's coming back in this way. It's like a circular, it is circular. It's a circulation. It's a cycle. So it's important that you understand that idea in your head. I mean, all this is an exchange. It's just this. It's you're going from your lungs to your cells and then back. Give oxygen to the cells, give carbon dioxide to the lungs, back and forth. So you've got oxygen going that way, you've got carbon dioxide going that way. It's just that the heart is the middleman. The heart is in the middle. Oh, I tried it. Making everything happen. It's purple because it means I don't love you. I'm in love with the idea. It's not a deeper thing. Don't want you to get confused. I mean, really, we should draw it like this. Instead of drawing it like this, draw it like this. Right? It's going in that direction, but it's got to go to the heart first. The heart's in the middle of all this. Probably doesn't help. But if you want to get oxygen from your lungs to all your cells in your body, you have to go through the heart first. And if you want to get carbon dioxide from all your cells out into the air so that you don't die from acidic blood, or if you want to get all that carbon dioxide out, you got to go through the heart. Cells give all that blood to the heart, then the heart will give it to the lungs so it can leave. You have any questions on that? Does it make sense? That's a better question.
It's better than the way you explained it earlier.
You mean with like the PowerPoint photo?
More like the packaging thing was kind of confusing. But like this is easy.
Well, you didn't like my building? This?
No, I like that.
So that's going to be like, what the
first
hell?
way.
Worked hard on that. It's a square
That's-
with 4 squares in a
That's
bigger
nice.
square.
It's what you were explaining earlier with the heart picture.
No.
So this picture and the picture next to you with the blue heart, they're pretty much the same thing, just explained 2 different ways.
Yeah, this, if you're going to be like, well, okay, but what's going on inside this heart? Then I would like point you over there. I'm like, okay, I opened the heart for you. Look, now you can see what's going on. It's the same picture. Because look, I'm saying from lungs, from cells. I'm doing it over here. From lungs, from cells. 2 lungs, 2 cells. The point is that the heart is sending blood to 2 different places at the same time. It's sending blood to all your cells, and it's sending blood right here to your lungs. And at the same time, the heart is getting blood from 2 different places. One from your lungs right here, and then the others from like the rest of the body. So if you like look at this, that's what I'm saying. It's like you're getting blood from your lungs, oxygenated blood, because you got to take this blood and send it off to benefit your cells. But the waste product from your cells, that's coming in on this side, and we got to send that to the lungs so that we can breathe out that waste and get some oxygen in there. And then once we get the oxygen, come in on this side. So these are like 4 rooms of this building. So these are the chambers. So there's 4 chambers of the heart. Right atrium, right ventricle, left atrium, left ventricle. Those are the chambers. There's a good video. There's a couple good videos you can watch on this. Not mine, of course, like good ones. One is for this Khan Academy. I like them. Just watch. Just like if you Google Khan Academy blood flow through the heart, they do a pretty good job on this. So, any questions so far?
No, sir.
I think I'm gonna stay up here for a while. All right, let me try to get less stuff going on here. I can take off right and left now. We know that. Let's take this stuff away just for a little while. Just want to kind of simplify it. So we got 4 chambers. 4 rooms. Remember that from your 4 years of high school French? Or Spanish? That you don't speak it? You know why you don't speak Spanish? Because you spent more time with Senor Frog than you did with Senor Rodriguez in high school. All right, so 4 chambers, 4 rooms, 4 doors. You got to go through a door, which I'm writing in purple. You got to go through a door before you can exit a room. By the way, it doesn't look like this like an actual version of the heart. I'm just getting you to understand like the idea. So when you want to go from an atrium to a ventricle, you got to walk through the door. But the door is a one-way door. That door doesn't swing the other way. It opens into the ventricle, but it will not open back into the atrium. It's like, it's like that door, right? It opens into the classroom, but I can't get it to swing the other way. And so what happens if what if I have it open like this, right? Let's say it's open like this, right? And then what if somebody threw a grenade in the room and all 25 people hit that door at the same time, right? Well, you're all going to be behind me. And what's going to happen is that you're going to smash me up against this door, and then everyone's going to be behind me, and I'm going to be like this. And I'm going to shut the door, and no one's getting out. Am I going to die? No. No, the grenade's behind me. Y'all protecting me. In your selfishness and trying to get out of the room, you've protected me now. So all of you die, I'll make it through. But that's not the point. The point is that this is how the valve...
That was dark.
Always thinking of myself. That's how these valves work.
Now we know how you actually feel when we're in class if something would happen like that. No.
Yeah, I'm not sure I would take a grenade for you. Bullet, yes. Oh, and it'll be a diving bullet. Like when I take a bullet for you, I'm going to be diving sideways. It's going to be awesome. So these valves don't, and I did the thing about running out the door on purpose because all the blood comes in through this door, but sometimes when the ventricle the ventricle is going to squeeze and contract and push everything out this door. Some of the blood tries to run back up that way. What they do is they hit the door. They hit the doors and they close it. It's all the blood ends up against that door. Right? It's open, but when they all try to go through, they slam the door shut. And then they can't get it, and then they can't get in. So then they turn around and go out that door. So these are all valves. The valves make sure that we keep things flowing in one direction. I don't want anything that goes in, I don't want the blood that goes into the shipping department. I don't want to go walking back over into the receiving department. No, that's it. You're in my shipping department. Your next step is to get on the FedEx truck. You're going out. You're not going back that way. So that's the valves. The valves keep everything moving in one direction. Same thing. You leave the house, you leave the building onto the FedEx truck. You're not going back into the building. No, wait, I got to use the bathroom. No. That's it, man. You're on the truck. You're gone. We don't want blood going back into the heart once it left the heart. That just makes things so inefficient. That heart is trying to pump. Every time it pumps, blood needs to move out. You can't have blood turning around, coming back in. You're going to screw everything up. You can't have blood deciding it wants to go wherever it wants to go. One orderly direction. In here, through here, out. So we got 4 valves. 4 chambers, and we got 4 valves. So the valves got names. These 2 up here, if I want to talk about both of those on the top, I'm going to call them AV valves. Just A for atrium, V for ventricle. So they're AV valves, right? You see 4 valves here. But I want you to look right now at the AV valves. So these 2. I'm not talking about these 2. I'm talking about these 2 between the atrium and the ventricle. Ventricle. But they each have their own names. So in purple, this one is, you probably know this already, call that the tricuspid valve. It's got 3 cusps. That's not important. Just telling you why they named it that. It's called the tricuspid valve. So in between the right atrium and right ventricle, we have the tricuspid valve. We've got another valve on the other side. You can call it bicuspid, but that's not the name that's always used. It's acceptable, but I'm going to write mitral. That's a more common name. M-I-T-R-A-L. It's a mitral valve. Some of you have probably heard of the mitral valve. But did you ever hear of the tricuspid valve? You would probably say, like outside of class, you would say no. I hear of like mitral valve prolapse and mitral valve this and that. I don't hear about like the tricuspid valve. So the tricuspid valve is definitely not as popular as the mitral valve. Well, the question is why? Like the tricuspid valve sometimes doesn't work well. But why does the mitral valve like seem to break down more? So we have to ask ourselves, well, where's this side of the heart going? Like, where's this blood? Wait. Where's this blood going? And where's this blood going? So where's the stuff on the left side going? Where's the stuff on the right side going? I guess I'm letting you think about it to yourselves. But feel free to say something like where it's going. This blood's leaving out to where? There it goes. Went to the door.
Other cells?
Yeah, everywhere. It's got to go down to my feet, to my pinky toe, and then this same ventricle has to provide the pumping action to go to my pinky toe and then turn around and come back up again. So it's got to pump it down to my pinky toe and then back around to up here. That's a big trip, going all the way down to my pinky toe and then back up against gravity. This is doing some work. This is going next door. Where's the lungs? Right here. Right here. That's an easy trip. You don't even have to get on a FedEx truck for that. You just go walk it next door. Probably still got your slippers on. Right, so that's not a big trip for this side to make. So this side works a lot harder than this side. So you're always going to hear stuff about the left side. I mean, you don't want any part of your heart to be jacked up, right? But sometimes when this tricuspid valve gets jacked up, it's not as big of a deal as the mitral valve. You hear a lot about mitral valve prolapses because like when this side gets jacked up, this is going all over the place. So it's a little bit harder of a job. In fact, if you look at the stomach, don't look at the stomach. If you look at the heart muscle on both sides, this muscle is thicker than this muscle. You could see it. But anyway, mitral valve or bicuspid if you want. Tricuspid, mitral. Those are the two AV valves. And then we got two, and they're not really located here. I just put them on the bottom. They're really located. It's really funky when you look at the heart, right? But I'm just trying to get you to understand the idea. These are called semilunar valves. So this one is on its way. Where's this blood on its way to? Going to somewhere right next door. You inactive people, you. Just sitting there waiting for someone else to answer. I'll say it. Oh, thank you. Yes, lungs. Okay. Yeah, see, you could type it in. That way you don't have to use your voice. You don't even have to make eye contact. It's going to the lungs. That's what she said, and she's absolutely right. So we're going to call this valve pulmonary for lungs, pulmonary valve. So that's the pulmonary valve. We're going to call this one, because it's going into a valve, it's going into a blood vessel called the aorta. We're going to call it aortic. I don't know if you can see that. So that's, you got four. So up here, we've got 4 chambers and 4 valves. Right atrium, right ventricle, left atrium, left ventricle, and then our valves. The 2 AV valves, tricuspid, mitral, and our 2 semilunar valves, pulmonary, aortic. You do not have to write pulmonary semilunar valve, just pulmonary valve. We know what everyone knows what it is. Okay, thoughts? Questions?
No, so far.
I'm going to now put back the PowerPoint slide and let's see if we can like really look at it like how it's supposed to look. So I think I got to share my screen with you. Bam, there it is. So now let's look at everything. All right. Let's do just chambers and valves. Let's do chambers first. right atrium, right ventricle. Right atrium, right ventricle. Left atrium, left ventricle. Doesn't look like the box I drew, but you've got atria, ventricle, ventricle. That's the 4 chambers. Now let's look at the valves. Here's the tricuspid valve. It's got these stringy things and, but this is a valve right here, like a kind of well, actually you can see it. It's like a little bit open. See the white part coming here? And if you were to look at these strings, it kind of looks like these strings here are pulling this valve open. That's not the case. It's the opposite. These strings are preventing this valve from swinging the other direction. They're keeping it. When it closes, this thing closes straight. That's what these little cords do. We'll learn the names of the stuff in lab, but the point is that these cords that you're looking at right now, they're not pulling this valve in the open position. They're just loose. They're not doing anything. They're going to prevent this valve. Like when this valve closes, it's going to close right here. It's not going to go up into here. It's not like a kitchen door at a restaurant, right? And that's because these cords are preventing that. So here's your mitral valve. Right, look, sometimes these cords, like you see these cords, sometimes they don't prevent that door from acting like a kitchen door, like a swinging door, right? Sometimes maybe this valve here won't stay straight. Maybe it'll just like open just a little bit into the atrium. And then you get blood that like trickles into the atrium. But anyway, look at the muscle. See how I was telling you it's thicker on this side than on this side. Because this side's going just pumping to the lungs. This side's going to pump everywhere. So this side, this is just in the middle. We call this a septum. Like the septum in your nose, between your nostrils. This is the septum between your ventricles. It's in between. It's a septum in between ventricles. Interventricular. It's a septum that's interventricular. So that's the interventricular septum. So you've got your 2 AV valves, and then up here, this is where I drew it way different. Here's your 2 semilunar valves. Here's your pulmonary valve. Really, so the blood comes in here, and then it doesn't keep going out. It swings around and does a U-turn, and then it goes this way. Now this is going out. Pulmonary valve, and out. And here's the aortic valve. So blood comes in here, goes out the aortic valve into this aorta. When you really look at the heart, it's a little more confusing because it's like going different directions and some things are in front of other things. It's kind of hard to tell where all these things are initially. All right, I'm going to back up a little bit and talk about this. So you see this meat? It looks like meat. If you've ever eaten a heart, it looks like steak that you would make fajitas from. That's it. I mean, if you give it like a good fajita flavor, you're not going to even know. So that's not the point, though. The point is what? We call this myocardium, M-Y-O. That's the myocardium. Cardium, heart. I think I got a slide right here. See? myocardium. That's the muscle of the heart. So they call a heart attack, they call it an MI. Myocardial, because of the myocardial infarction, because your myocardium is all farked up and you have an MI. But look at this little white lining, I guess. So we call that the endocardium. And then look out this other white line here. We call that the epicardium. So let me show it to you again on the heart. Right here. This white line here that I'm kind of tracing, that's endocardium. This is myocardium. And then this right here on the outside, epicardium. Epicardium. Endocardium. Epicardium. Endo inside, epi out. Good? Hope I'm not going too fast. This is really just anatomy stuff. Okay. Look at, I don't know what to look at. I'm thinking. Well, okay. Whenever you cut open a cadaver, whenever you cut open something, the heart doesn't look like that. It doesn't look like that at all. There's a sac around that heart. You have to cut the sac. And when you cut the sac, some fluid's going to come out of it. And then you've got to like pull that sac away. Then you're going to see this heart like on this photo. Except it's not colored. But I mean, you get what I'm saying. So there's a sac around your heart. It's not just sitting there like they show on TV. Right? It's not just sitting there. There's a sac, and it's called the pericardium. That's what this thing is supposed to represent. Right? So there's a pericardium around your heart, and it's filled with pericardial fluid. In hospital settings, you'll run into cases where these things become inflamed. Pericardium becomes inflamed, pericarditis. That's something that you would come across, because people that have it are complaining. Endocarditis, this inner lining, like the lining here, that could become inflamed. That's one of the, I don't know, they say that that's one of the side effects of one of the vaccines. I don't remember anymore. I can't keep track. But it was endocarditis, right? The lining of like the atrium and ventricles would become inflamed, right? You will see that in a hospital setting, because there's lots of things that can cause it. It's often a bacterial infection will cause that. But yeah, this heart's covered with it's not just like, what happens when you jump up and down? Is your heart just like bam, bam, like that? It's in this fluid. It's got some protection to it. Oh, I wanted to show you that. Okay. Here's the back side of the heart. All right, so let's look at the inside one more time. All right, so let's look at some, like, what's going into the atria, right? We know that deoxygenated blood goes into the right atrium. Where is it coming from? Well, here's two places. This big vein here and this big vein here. Superior vena cava, inferior vena cava. They're both bringing blood back into the right atrium. So all the blood coming down my neck, my jugular vein, around my arms and shoulders. That's all coming into one big, large vein above your heart called the vena cava, superior vena cava. And then all the veins in my legs, gonads, whatever, everything that's below my heart, kidney, spleen, all those veins are converging into this one, called the inferior vena cava. So those two veins are coming in and they're both emptying. So like, there's like a hole for that right here where my cursor is. And like, here's the hole for this. And they're both filling this atrium with blood. So the right atrium is getting blood from the inferior vena cava, the superior vena cava, and one more place I'll talk about later. It's a little place. Let's look at the left side. Left side, left atrium. It's getting, if you look inside the left atrium, there are 4 holes. There's 4 openings. Here's 1, 2, and you cannot see the other 2, but they are right back here, like 3, 4. Right, so there's 4 holes in here. 1, 2, 3, 4. They are all coming from pulmonary veins. Here's 2, and you can see like the opening for this one. Right, these 2 are converging into one. Right, so there's a pulmonary vein. There's a pulmonary vein. Here's the other pulmonary vein, and here's the other pulmonary vein. They're coming behind the heart, and then they're going in here. I'll show you the back side. See, there they are. So those are coming behind the heart, and then they're just emptying here. Now, there's something here that's different. This is a pulmonary vein, but it's red. It's not blue. All the veins that we've been looking at are blue. This one's red. Because a vein is something that brings something to the heart. It doesn't matter what kind of blood is in it. It's something that's going toward the heart. So these veins are on their way to the heart from the lungs. So we call them pulmonary veins. They're carrying oxygenated blood that they had just gotten from the lungs. So because it's going to the heart, we're going to call them pulmonary veins. And even if you look here, this is a pulmonary artery, but it's blue because artery is going away from the heart. This is going from the heart to the lungs, back in from the lungs, out from the heart to the lungs, back to the heart from the lungs. So when you have these words pulmonary here, it's kind of reversed, right? This is not a vein. I mean, a vein, this vein is carrying oxygenated blood. I'm sorry. This vein is carrying oxygenated blood. See, I did it. This vein is carrying oxygenated. This artery is carrying deoxygenated blood. Does anyone have any questions? You guys want to take a break or something? What time is it? All right, let's take a break for like 10 minutes. 10:25, we'll go to 11. I got to charge my computer. I feel like I've lost some of you.
A little bit. I'm gonna have to rewatch the video a few times.
Okay, I'm gonna stop recording now for the break. Then maybe I'll show someone else's video. It's always nice when I get someone else to do my job.